The principle of NOT gate is based on inversion of the input signal which is visible on LED light. That is, when the input signal is 0, it means no electricity, LED should be on. On the contrary, when the input signal is 1, the LED should be turned off. Turning on-off principle is maintained by transistor and the input signal is given by pressing a button to the base of transistor. When the transistor is open, meaning there is an electricity given to the base, current flowing to the LED is interjected. As the current always decides to flow with the path of lower resistance, when the transistor is open, the resistance between its collector and emitter is much lower. To that end, the current flows to the collector, then to the emitter, and from emitter to the ground, neglecting LED. On the other hand, when the transistor is closed, current has no other place to go except through LED and to the ground, turning it on.
When AND condition is satisfied, current will flow to the collector of the AND transistor, and from long path it will be guided to the ground, omitting the NOT transistor. This will make the current going to the NOT transistor flow instead to the LED, turning it on. Bases of these transistors are regulated by buttons. When the buttons are both pressed and AND condition is satisfied, the LED should turn on. For this occur, the current going to the NOT transistor's base must be disrupted. The current going to the base also must be connected to the collector of the first AND transistor. Hence, the NOT transistor must take the current to itself and flow it to the ground through collector to the emitter. For that, it must be opened, meaning the current must be given to its base. Approaching to the AND principle, two transistors are used to guide the current from the collector of the one transistor to the emitter of the second one, achieved by connecting first transistor's emitter to the second one's collector, and the second one's emitter to the ground. The principle of AND gate is based on simple logic where both inputs must be 1, so result is 1. The result of this gate will be visible on LED, whereas the switch mechanism is still enabled by transistors, but this time 3 of them. By extending the notion of the NOT gate, initially when the condition for AND is unsatisfied, LED must be turned off. Note: 2K and 330 ohm resistors are used for transistor base and LED respectively.
The principle of OR gate is based on simple logic where both inputs must be 1, so result is 1. The result of these gates will be visible on LED, whereas the switch mechanism is still enabled by transistors, but this time 3 of them. By expanding the notion of the NOT gate, initially when the condition for OR is unsatisfied, the LED must be turned off, hence the NOT transistor must take the current to itself and flow it to the ground through collector to the emitter. For that it must be opened, meaning the current must be given to its base. Approaching to the OR principle, two transistors connected parallelly are used to guide the current from the collector of either transistor to the emitter of those, achieved by connecting both transistors' emitters to the ground while collectors with each other. Base of these transistors are regulated by button. When the either button is pressed and OR condition is satisfied, the LED should turn on. For this occur, the current going to the NOT transistor's base must be disrupted. The current going to the base also must be connected to the collector of the first or second OR transistor. When OR condition is satisfied, current will flow to the collector of the OR transistor, and then from the any open transistor's emitter to the ground, omitting the NOT transistor. This will make the current going to the NOT transistor flow instead to the LED, turning it on. Note: 2K and 330 ohm resistors are used for transistor base and LED respectively.